Okay, this is some problems that were emailed to me from the Unit 3 review, starting with number 1, Part A. We're looking at turning this standard form quadratic equation into vertex form and then stating the vertex. So what we need to do is we need to complete the square here. And remember, when we are completing the square, that we will have to make sure that there's a 1 in front, which in this case there is. If there was not, we would have to pull something out as a GCF. So for this very first one, we're going to separate out the variable term from the non-variable term. We take half of the middle term and then square that. Since it doesn't divide evenly, you're going to square just top and bottom and keep it as a fraction. So this would be f of x equals x squared plus 5x plus 25 over 4, and then minus 8. And then to counter this, since we didn't have to pull out a GCF, the counter will also be negative 25 over 4, because you need a positive and a negative to counter it. So then when we factor that, that would be x plus 5/2 squared, because remember it's right before you squared it, that's what it factors into. And then we would need a common denominator here. This would be negative 32 over 8. Excuse me, I did the wrong one, over 4. Because we think of this as 8 over 1, and we would multiply top and bottom by 4. So negative 32 over 4 minus 25 over 4 would be negative 67 over, or 57 over 4. So my vertex is the opposite of what I see inside the parentheses, so that'd be negative 5/2, and exactly what you see at the end, so negative 57 over 4. So this right here are the two answers that you would need. The vertex form and then the vertex. The next question that was posed was how do you deal with a problem in part 2, which is how do you graph a quadratic. So we're going to do a couple things. We want to know whether or not the parabola is going to open up or down. We want to know the vertex. We'll want to know if there are any x-intercepts, if there's a y-intercept, and we'll want to know the axis of symmetry. After we find all that, we'll then graph it on a grid. To know if it opens up or down, you look at the leading coefficient. Since this is a negative, that is going to be opening down. That means my parabola should be an upside down U. The vertex is found by doing negative b over 2a for the x-coordinate. Now, so this is for vertex. The problem is you don't have a b coordinate here. There's no x term. So a lot of students will use the 9 as the b, but it's not the b. Remember, in this format, ax squared plus bx plus c, the b term has to have x to the first power. So this is actually negative 0 over 2 times negative 1, which is just going to end up being 0. And then we plug in 0 to find the y value. So f of 0 equals negative 0 squared plus 9, so that's just going to be 9. So that's actually our y-intercept, because remember, y-intercepts are 0, comma number. So the vertex of this parabola is actually its y-intercept. To find the x-intercepts, you will have to factor. So negative x squared plus 9, we need to equal to 0. I would factor out a negative 1 first. And so that would make that minus 9 in there. And then this would be x plus 3 and x minus 3. So we get two different x-intercepts, negative 3 comma 0 when we solve this first parentheses, and then positive 3 comma 0. The axis of symmetry is always a vertical line through the x-coordinate of the vertex, so x equals 0. So if we plot our points, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's my vertex, and then 1, 2, 3, negative 3, and 1, 2, 3, positive 3 are my two x-intercepts. And notice my parabola is shaped down. The next question that I was asked about was to do one from number 6. I'm going to do B part since it's not factored already. If it's factored already, you just jump right into the X-intercepts. So I need to pull an x squared out of this. That would make that x minus 3. Pull out a negative 9 out of this one. That would make that x minus 3. So then I get x minus 3 that they shared in common, and then x squared minus 9. This factors into x minus 3, and then an x plus 3, and an x minus 3. This is this part right here. So we actually get x minus 3 to the second power, and x plus 3 to the first power. Okay, so my x-intercepts are positive 3 and negative 3. Positive 3 has a multiplicity of 2. Negative 3 has a multiplicity of 1. Remember, that's its exponent here on the factor, which means at positive 3 we're going to have a bounce, and at negative 3 we're going to cross straight through. Other things we should note, the leading coefficient is positive, because this is our end behavior. So for end behavior, we care about the leading coefficient sign, and the highest degree, since this is in standard form, is a 3. Notice that you could also get that from factored form by adding the powers. So this would be odd and positive. So remember, that means you are down on the left and up on the right. So we should now have enough information to graph this piece. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We don't really care about how high or low the curves are going to get. So we have a point at negative 3 and one at positive 3. On the left we're down, and on the far right we're up. At negative 3 we're supposed to cross, so we go up. But at positive 3 we're going to bounce, which makes sense because it's on the upside, but then it bounces right back up. Then the last part is you have to describe these two things. F of x is greater than 0 when we are at negative 3 to 3, because that's above the x-axis, and from 3 to infinity. F of x is less than 0 on negative infinity to negative 3. Okay, numbers 9, 10, and 11, I was asked to graph these. So the reason I'm glad that these were asked is we can talk a little bit more about the horizontal asymptotes long division case there, because I felt like we didn't get to see as much variety as I wanted in class on those. So the first thing you want to do on these is to factor the denominator. So we're going to start with number 9. So that's x plus 3, x minus 3. Nothing's going to cancel in this problem because this 6 is a monomial, these are binomials, nothing matches. So we go ahead and start off with our domain, because there'll be a list of things that you'll be asked to give on these problems. Domain is anything except negative 3 and positive 3, because those are both restrictions for the denominator. The x-intercepts, there are going to be none. X-intercepts only occur if there's an x on top after reducing, and there's not. Vertical asymptotes are anything that's in the denominator that doesn't cancel out. So, and they are vertical lines. So x equals negative 3, x equals positive 3. We get that from solving both of those equal to 0. Holes only occur if you have something cancel out. Since we didn't, we have no holes. Y-intercept, might as well go ahead and find that. You plug in 0 for x. So 6 over 0 minus 9, 0 squared, sorry. This would be 6 over negative 9, so that's negative 2/3. So 0, negative 2/3. And then we have this idea of horizontal asymptote versus oblique, because you have one but not both. If you try to do long division with this problem right here, x squared minus 9 cannot go into 6 at all, because this is already bigger than this. So this is 0, and it doesn't go at all. So this is a horizontal asymptote because all we got on top was a number, and it's actually the x-axis. So if you can't do the long division at all, your horizontal asymptote is 0. And that means we have no oblique. So if we put all this information onto a graph, we can see what other extra points we might want to plot. So 1, 2, 3, I have a vertical asymptote at -3. Put a couple slashes after. I have another vertical asymptote at +3. I have a vertical asymptote at the x-axis, which is y = 0. X = 3, x = -3. And then I have one point of 0, -2/3 is my y-intercept. So notice that we have 4 different regions here. We have a top left, a bottom left, a middle on the top, a middle on the bottom, because I'm kind of using the dashed lines as my regions. I have a top right and a bottom right. I should have said top left, bottom left over here. So you have essentially 6 regions. In each of these little subintervals on the left of this vertical asymptote, in between these 2 vertical asymptotes, and on the right of this vertical asymptote, we want to know if the points are happening either above or below, because that will tell us where our graph is getting kind of fenced in. So I'm going to pick some points on the left of -3, so maybe a -4. I'm going to pick and maybe -5 as well. And then I'm going to pick a few points in the middle, not using 0 since it's already been used for the y-intercept. So maybe -1 and +1. And then I'm going to pick 2 points bigger than 3, so maybe 4 and 5. And I'm going to reorder those first 2 so they're in least to greatest order. So -5, then -4. Okay, so plugging them into our equation. So this is all going back into the equation. -5 squared would be 25. 25 minus 9 is 16, so that's 6/16, which would reduce down to 3/8. That will also be the answer for +5, because when you square +5 and -5, they both turn out to be +25. -4 squared is 16, minus 9 would be 7, so this will be 6/7. And that'll also be true for +4. -1 squared would be 1, minus 9 would be -8. So that would be -3/4, and we'll get a -3/4 as well for +1. So there's some kind of symmetry there. So -1, -3/4, +1, -3/4. So notice this looks like these are going down towards those asymptotes. So that's our middle section. We need to do our left section. So -4 6/7. I'm going to put a mark here. That's about right there. And -5 3/8 is a little less than half. So it looks like these are being bound by these 2 dashed lines. And then on the right side of this other vertical asymptote, we have that you have 4 6/8 or 6/7, and then 5 3/8. So you get kind of this matching symmetry over here. Now, where students usually go wrong in graphing rational functions is that they only do like a certain region. They forget to do all the regions. The only place you should not have graph is on your vertical asymptotes. So you should have graph everywhere else. Number 10 is very similar. I believe the only difference is that everything stays positive because there's no minusing anything in the bottom. So I'm actually going to, I'll do this one last. I want to talk about 11 next. So I'm going to give myself some space. So f of x, we're going to factor the top. This would be x minus 3 and x plus 2. On the bottom, it would be x plus 3 and x minus 2. So nothing's going to cancel out because all the signs are wrong. They don't match up. So my domain, let's go ahead and write that. X cannot equal -3 or +2. That comes from the denominator. X-intercepts, since nothing cancels, we actually cross the x-axis twice. the top would be at positive 3, 0, or negative 2, 0. For the vertical asymptotes, nothing canceled out, so it would be both of those bottom pieces. So this would be a negative 3, so x equals negative 3, and a positive 2, so x equals 2. Notice x-intercepts are ordered pairs, vertical asymptotes are equations. Holes, nothing canceled, so we don't have any. Let's see, y-intercept. If we plug in zeros for all the x's in the original, notice if I just go back up here, 0 squared minus 0 minus 6, 0 squared plus 0 minus 6. That's just going to be negative 6 over negative 6. That's positive 1. So 0, 1. And then horizontal asymptote versus oblique. So if we try to do the log division with the original problem, so x squared plus x minus 6 into x squared minus x minus 6. X squared goes into itself one time, and I can go ahead and do the multiplication if I want, and then change all my signs, and we get a negative 2x, and that's it. But this can't go into this any further because x squared is bigger than negative 2x, so it's just going to be y equals 1. So if you don't get an x on top, you have a horizontal asymptote. If you were to get an x on top, you would have an oblique, but we're not going to make you graph any obliques, so you shouldn't have to worry about that. You could have to graph a horizontal, though. So let's put this information down onto the grid, see what we have. So 1, 2, 3, that's an x-intercept. Negative 2 is an x-intercept as well. Negative 3 is a vertical asymptote. Positive 2 is also a vertical asymptote. Y equals 1 is a horizontal asymptote. And let's see, 0, 1 is a y-intercept. Now, because our y-intercept is on our horizontal asymptote, it is very, very likely that this is crossing through here or touching and bouncing back. So we're going to need to investigate that by plugging in positive 1 to see if this actually crossed all the way through and went up, or if it bounces back down. But obviously it's definitely touching or crossing at our horizontal asymptote here. That's okay. You can cross a horizontal asymptote. And like I said, we won't give you that on the test, but I did put one on the review so you could kind of see that. But the way to know for sure is just to test another point on the other side. Okay, and there was none for the oblique, by the way. So if I plug in something to the left of negative 3, so we're going to plug in negative 4. Something, I'm pretty sure what this is doing, it's going down here, but maybe to the right of this point, so we're going to plug in positive 1, that's something from the middle. And then I'm pretty sure this is in the down area right here, but I'm going to plug in positive 4 to prove that. So then my formula was x squared minus x minus 6 over x squared plus x minus 6. So if we plug in negative 4, that would be 16 minus a negative 4 would be plus 4 minus 6 over 16 minus 4 minus 6. That's going to be 20 minus 6, so that is 14 on top. And that is 6 on the bottom. And 14 divided by 6, if we reduce that down, that would be 7 over 3. If we plug in positive 1, that's 1 minus 1 minus 6 over 1 plus 1 minus 6. That would be negative 6 over negative 4. That's going to turn out to be a positive 3/2. And then if we plug in 4, that'd be 16 minus 4 minus 6 over 16 plus 4 minus 6. So it's just reversing this. So this would be 6 over 14, which is going to be 3/7. So that should be enough to get us points to graph this. 7/3 is 2 1/3. So that means that point's up. So I'm guessing that means we're bounded in here. This guy was 1 3/2, so that's right here. So definitely this actually crosses that horizontal asymptote and goes up, so down on this side, right on this side, or up on the right side. And then 3/7 is going to be, hold on just one second, my PDF crashed. Okay, so I'm back. 3/7 is that last point that we need to plot. So let me get my pen back. And this is at +4 3/7. So notice this is staying below that horizontal line. Okay, so how do I know for sure that this is the only place this crosses the horizontal asymptote? The quickest way to see this is to take the equation, which this was our equation, and you set it equal to the horizontal asymptote, which is 1. You then cross multiply, so it's 1/1, so this will just be x² minus x minus 6 equals x² plus x minus 6. You try to solve for x, so we're going to subtract over the x squareds. So this is -x minus 6 equals x minus 6. And then we try to solve for the x's, so I'm going to add the x over. So that would be 2x minus 6, add the 6 over. That's 0 equals 2x, divide by 2. Notice I was able to solve this for x. There actually was an x at the end. Most of the time when you try to do this little trick to see if you cross the horizontal asymptote, all your x's cancel out and you don't get anything but 2 numbers. We were able to solve for x. What that means is that we cross at the point 0, 1. The 1 comes from the actual horizontal asymptote. So we cross at that value. So notice that's where we crossed at, was at 0, 1, and it will be the only place that we can cross at because it's the only solution that came up when we solved this. Now, we're not giving you one on the test that actually crosses the horizontal asymptote, so you won't need to do that extra check, but it's good to know that this makes sense, that this crossing here follows that rule. All right, the last one was 8/x², so I'm going to have to do that one on a separate page. Because I do not have room to write it out. So let me get my ink. So f of x equals 8/x². Domain here, nothing you can factor in the bottom, but we definitely don't want x to equal 0 because that would be undefined. X-intercepts, there are none because there's no x's on top. Vertical asymptote, it's going to be x equals 0. It's whatever that restriction is as long as it's not canceled out. There are no holes because nothing cancels out. Let's see, y-intercept, if you plug in 0 for x, that's undefined, so there is not one. And then horizontal asymptote versus oblique. If you try to do long division here, this again does not work. X² cannot go into 8, so it's horizontal because it's just a number. And it will be the x-axis, and then this is none. So we plot what we know, and I can use different colors here to emphasize my asymptotes. So I have this vertical asymptote at x equals 0. That is a vertical line through the y-axis, and then I also have a horizontal asymptote at 0, which is the x-axis, so y equals 0. Horizontal lines are y equals, vertical lines are x equals. So notice I have pretty much 4 regions. It's the 4 quadrants specifically in this case. We do not have any intercepts, so we're going to have to pick points on each side to figure out what this is going to look like because we don't have any ordered pairs to work with at this point. So I'm going to pick let's see, where's my pen? I just added some kind of annotation thing. There we go. How do I get that to go away? Delete. Okay. So I'm going to pick points, pretty much just negatives and positives, so I have stuff on each side of this vertical asymptote. So maybe -2 and -1 and 1 and 2. We plug them in. So 8 divided by -2 squared, that's 8 divided by 4. So that's going to be 2. 8 divided by -1 squared, that's going to be 8 divided by 1. So that's just going to be 8. And these will actually be the same thing because it doesn't matter if it's positive or negative because you're squaring it. So they all end up positive. So we plot the points. So -2 up 1, 2. And then -1 up 8. And then +1 up 8. And +2 up 2. So notice this is staying in this top region, and so is its counterpart on the other side. So both of these are up because x squared doesn't have anything subtracted from it. It doesn't have a negative in front of it. It's never going to be negative. So everything's going to always come out positive since you're doing 8 divided by a positive number. And that's it for the questions that I've received so far. So I will post this to the YouTube channel, and if I get more, I will post a second video after that. All right, you guys have a good weekend.